Oh, well, yeah, I don't know what's going on here. But we're just going to go ahead and get started. So, cool. All right. Well, and that's go in there. Cool. Well, hey, everyone. My name is Tyler. I'm a software engineer on the PowerShell team at Microsoft. And if you want to follow me on Twitter, I'm at Tyler Leonhardt. I tweet a lot about PowerShell. And yeah, so if you want to follow me, go for it. So this talk is about PowerShell IoT. Now, for those of you that were here for the raffle that we did earlier, you saw the demo where I have this like QR code scanner, and I like scanned the QR codes on your badge. And then it showed up on this little LCD screen, and then I hit a button, and someone won, and everybody clapped. Well, I don't know if they did that part, but yeah. So that's using this module that we have called PowerShell IoT. So this talk is all about how to get started with PowerShell in the IoT world. So the agenda for today is to talk about PowerShell on ARM devices. Specifically, we're going to be talking about Raspberry Pis, which are the things I have up here. And then we'll dive into the PowerShell IoT module that controls all of these sensors and devices. Then we'll hop into a demo where we'll look at a PowerShell IoT-based module. And then we'll look at some PowerShell IoT modules that are out in the wild. So, in case you didn't know, I should define a certain three-letter acronym that I continue to use over and over again. And of course, that's IoT. What does that mean? Well, if you don't know what that means, it means Internet of Things. All right? So Internet of Things, the things of that are small computing devices like these Raspberry Pis, for example. And sure enough, they're typically connected to the Internet. Internet of Things. There we go. They usually control different hardware sensors and devices. So I've got like the button that you saw, the LCD screen, and in the demo I'm going to show today, I've got like a little touch sensor. There are some common protocols out in the IoT world. These are a few of them: GPIO, I2C, SPI. You don't need to know these. Don't let them freak you out. Some of them are easier than others, but we'll take a look at those a little later. And then in the Internet of Things space, we also have these things called smart products. You think like smart refrigerators, smart toasters. Yeah, so like smart refrigerators on the Internet of Things. No one knows if you're a fridge. And then smart thermostats. I thought this was pretty funny. I think my Nest smoke alarm is going off. Google AdWords just pitched me a fire extinguisher and an offer for temporary housing. There's just a ton of really funny IoT jokes out in the wild. But specifically what we're going to be talking about is more of the prototypey aspect of IoT, which is stuff like this, the Raspberry Pi, which you saw earlier today. So another example is there's this little LED matrix here, and good, my videos are working, and it's like flashing the PowerShell logo. And all of that is controlled via PowerShell. So as Jeffrey mentioned in the beginning, PowerShell's historically been about managing Windows, right? But with PowerShell Core and moving forward, it's really about managing anything from anywhere. So that includes just all of the OSs, Windows, Mac OS, Linux, and also on a bunch of different architectures as well. And the important one here is ARM. And if you're curious about more things that are happening in PowerShell Core, Steve, my manager of the PowerShell team, is giving a talk. I don't know if it's later today or tomorrow, but check that out. He'll be talking about a lot of PowerShell Core stuff. But since we have PowerShell on Linux and PowerShell on ARM devices, that means we also have PowerShell on, on Raspberry Pis. So here's a picture of what one looks like. If you didn't see it from the previous picture, we've got like these little pins at the top there, and you connect wires to them into different sensors like temperature sensors and touch sensors or LCD screens, et cetera, et cetera. So what does PowerShell on Raspberry Pi mean? Well, the Raspberry Pi can support a bunch of different OSs, but the big ones that we care about are Raspbian, which is kind of the go-to Linux variant, and then Windows 10 IoT. So we have PowerShell working on both Raspbian and Windows 10 IoT. And of course, that's PowerShell Core 6. And since it's PowerShell Core 6, we also get PowerShell remoting over SSH. Now, for those of you that don't know what SSH is, it's kind of the default, the standard remoting protocol on Linux. And as of recent, it's shipping in Windows too, which is really cool. There's a sister team of mine that's been working on porting a lot of OpenSSH to work on Windows, so we have native support for SSH on Windows now too. So I foresee that SSH will be the standard for remoting going forward. But until then, we have PowerShell remoting over SSH and PowerShell remoting over WSMan, WinRM that we used to before. The experience is very similar. It's just a different parameter. It's very simple to use. We'll take a look at that in this. So before I jump into the demo, I want to also talk about the PowerShell IoT module. And so what that is interacting with sensors and devices in a very PowerShell-friendly way. So actually just typing commandlets and getting access to those hardware pins that we see on the Raspberry Pi. It supports these common protocols that I touched on before. Today we're going to look at specifically GPIO, which is like the simplest one, and this touch sensor that I have in the demo. And the main objective of the PowerShell IoT module is not necessarily for people to go out and just use the PowerShell IoT module, the one module to rule them all, but it's really a framework for writing modules on top of it. And so to get a sense of what that means, at the bottom we've got our Raspberry Pi and we've got PowerShell running on the Raspberry Pi. Then on top of that we have the PowerShell IoT module, and that exposes a bunch of different commandlets: get GPIO pin, set GPIO pin, etc., etc. And then from there, you as the module developer will leverage the PowerShell IoT module to make hardware-specific modules. So for this demo, I made a module for this touch sensor, and I've exposed a commandlet called getTouchSensor, which will give you that Boolean true or false of whether or not something is currently touching the touch sensor. That way, you could distribute your hardware-specific modules, and they're a lot more readable than get GPIO pin, set GPIO pin. So let's go ahead and dive right into a demo, assuming it's still up and running. So, all right, so I've remoted into my Raspberry Pi here, and I've got Raspbian running on it. So I can go ahead and open up the shell here, and don't worry about, let's see, how do I, is it this? Yeah, there we go, zoom in. And I could go ahead and start PowerShell. Now notice I'm starting with sudo, and the reason I'm doing that is because in order to access the hardware on the Raspberry Pi, I need to run PowerShell as root. And so I need to run PowerShell with sudo. Now down the road we want to add being able to do sudo into and in front of any arbitrary commandlet, but for now we have to do it this way. So as you can see, I have PowerShell 6.1 right here, and I can look at the PS version table and see that it says Linux, and we've got 6.1 and all that sort of things. So it's really cool. And then, well, actually, we can just go ahead and get rid of this remoting session, because all we need is PowerShell remoting over SSH. So let me zoom in here. Zoom, 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 zoom. Can you guys see that all right? Cool. And we can do just as we would with WSMan, we could do enter PS session. And this time, instead of like computer name or something like that, I'm going to use host name. And then the syntax we use here is similar to what you use in SSH itself, which is pi, which is the username, @ and then the IP address, which I forgot to copy over. So let me grab that real quick. Okay. Now, Another thing I should note is, remember I mentioned that you need to run PowerShell with sudo. So there is one quick change that I needed to make in order to get this to work. Now, when you set up PowerShell remoting over SSH, and I actually have the link on how to do all of that in my slides, and you guys will get that through some magical means. But you have to make an addition to your SSH configuration. So let's go ahead and look at what that looks like. So it's under etc ssh sshd _config. Right? So I've opened it in VI, but you can open it in whatever text editor you want. And let's go ahead and search for PowerShell here. Now, the instructions will tell you to add this second line here. If you could see that, it's a subsystem, PowerShell, and then the path to the PowerShell executable, and then you pass it these parameters. Now, since we need sudo, I've added another subsystem called PowerShell-sudo, where I've specified sudo before pwsh in this case. Now, in order to take advantage of that, we can go over to our prompt and just do -subsystem, PowerShell-sudo, for example. And so then, after I put in my password, now keep in mind the Raspberry Pi is not the most powerful machine in the world, so this is definitely a lot slower than my Mac. But just like that, we are now remoted into the Raspberry Pi that's sitting 3 feet away from me, because I'm lazy and I don't want to see a GUI. So now that we're remoted into this, let's go ahead and use the PowerShell IoT module. So if I do get module list available, Microsoft.PowerShell.IoT. Actually, what I should have done is get command module Microsoft PowerShell IoT. We see the command list that I showed earlier: get GPI open, set GPI open, etc. So let's go ahead and use that now. When I set this up, I put the touch sensor on pin 7, so I can do get GPI open -ID 7, and sure enough, the ID of 7, the value is low, and if I were to hold it down, which I will do now. Did it work? It says hi, which is awesome. Yeah, so we just used PowerShell to interact with this piece of hardware in front of me. So that's crazy. We've never done this with PowerShell, as far as I know, before. So as a cool example, we could do, let's see if it's in my history. Yeah, let's do this. Ready? It works. Impressive, says the guy presenting. So that's great. It worked. So let's see. What else should we do? I think that's enough of an introduction. Let's go ahead and hop back to the slides for a sec. And we'll talk about the module that I came up with. So that's So the module I came up with is PS Touch Sensor, and it leverages PowerShell IoT, like we saw in that blocky example, and it provides a PowerShell-friendly interface for that touch sensor that you see there. So let's go ahead and take a look at that. All right, so I have it here. You know what? I never started the recording. Woo! All right, now I've started the recording. They're going to kill me for that, but that's all right. All right, so PS Touch Sensor. Can you guys see that? I've got a weird skin for GitHub. I guess I can disable that. There you go. That looks a little bit more normal. So PS Touch Sensor. I've got the repo here up on GitHub at github.com/Tyler0706/PS-touch-sensor. Check this out. It's got all the resources for this talk as well, so there's kind of just one place you need to go. So let's go ahead and open this up and look at some of the code. There's also some gotchas, which are really important. So let's get rid of this session. We don't need that anymore. And I'm going to go ahead and open up VS Code. I use the insider's version of VS Code. You can use the regular one. All of this works just as you would expect. And so let's see. Okay, so we've got some tests. Well, we got a test that says can get the value of the touch sensor, and if it's not running on a Raspberry Pi, then it won't run that test, which is pretty cool. Some pester tests for that. We get the result of the commandlet and assume it should be true. Let's see what else here. A build.ps1 that will install the IoT module and pester if need be. This is really for like developing the module locally, and then a test step that will run the pester tests. Okay. Sorry? Oh, increase the font. Yes, of course. Sorry. Ooh. Slide this over, and let's just make that there. Okay, cool. Here's the whole code. We set a default pin, and then it's really quite simple. Get GPIO pin of the pin that was passed in, or the default pin, and if it equals high, then we return true or false. Pretty simple stuff, and of course the module manifest with the function that you export. Now, for those of you that were kind of looking at what was going on here, you notice that I've got an Azure Pipelines.yaml, which means that this project actually has CI, and it's passing. Now, one thing that you could do with the Azure Pipelines, which used to be called VSTS, and then we changed the name, and now it's called Azure Pipelines. One of the things that you could do is run an Azure Pipelines agent on any device, any operating system. And the big one for me, which came out relatively recently, I don't think they've done an official release of this yet, except on GitHub, is one that works on ARM devices. And so I actually have an Azure Pipelines agent, Linux agent, running on the Raspberry Pi. Now, that sounds scary. They have some amazing documentation on how to get that set up. It's actually really quick to do. And I think my repo has a couple gotchas on some lessons learned from setting that up. But really, this is the important part, this YAML definition. And the important step is really just this, which is start PowerShell with sudo, because we know we need that because of hardware, and then run that build script that does the bootstrap, which will install the dependencies, and then test it. And that's it. And then we publish the test results so that it can actually like show the results of the tests, obviously. And that's pretty much it. So what I was thinking is we've got this like hard-coded value of 7 for the default pin, but ideally people might want to change that. They might want to change it to whatever value they want. So I figured what we would do is submit a PR that would add another commandlet called set PS touch sensor default pin. And so I've actually got some of this code already done. So for example, it's a really simple commandlet. All it does is exactly as the name implies, it just sets that default pin to that, and then get PS touch sensor will then use that value that we set it to. Really quite simple. And let's also be good citizens and write a test for that. So we have a test here. If you're wondering how I'm generating all this code, I'm using a VS Code feature called snippets. And recently, like very recently, like this latest release, I believe, they came out with this thing called workspace level snippets. And there's like actually in this .vs code folder, you can have this like .code snippets file, and you can define snippets just like this very quickly and easily. And this is a great use case for stuff like, if you have a header on all of your files for your repo, you can easily just make your own snippet for your header and ship it a part of your project, which is very helpful and very handy. But anyway, back to this. So All right, I've added my test. I've added my code. I do need to go and update the PSD1 to add set PS touch sensor default pin. Cool, it's there. And we should be ready to go. We probably should do, let's see, it's 11:55. I know I do have more time because of the whole going overtime, but I won't try to keep you guys here too long. So let's go ahead and get through a brief version of it, and then I'll go back and we can mess around some more. So actually, let's just use the VS Code GUI here. So now I've made all my changes locally. In VS Code, I can review my changes here, which is really handy if you've not messed around with this. So I can see that I added all this code to this simple stuff. And so now I want to make a pull request. So let me go ahead and create a new branch, and I can do that in VS Code as well with here. And let's call it add set PS touch sensor default pin. All right. I've switched branches now, and so now I can add all of my changes. Added set PS touch sensor default path, default pin. All right, so this will commit it to my local repository, and then the last thing I need to do is hit the, is it this one? I think it's this one. Yeah, publish changes, and that will go ahead and push that up to GitHub. Don't need to memorize any Git commands. I can just do it all right here in VS Code. Although knowing those Git commands is very useful. So back into GitHub, I'm already prompted with a add set PS touch sensor default pin PR, so I can, or sorry, with a push to that branch, so I can go ahead and open up a pull request just like that. Let's take a look at the changes that I made. So I added this. I added this function and that code. Cool. So everything should be good. So let me go ahead and create this pull request. And we'll see that CI gets kicked off. Now, there is one thing that needs to be done before this runs, which is I noticed that in my tests, I depended on this here to succeed. I depended on if something is touching the sensor, which is not. So I need to touch it. Now normally, it'd bring some tape or something like that, but you're probably not traveling to Singapore when you're messing with this stuff. So I digress. So CI succeeds. And this is all like a part of the Azure Pipelines thing. And we got a green check mark, which is awesome. So then all checks have passed, and we can go ahead and merge that in. And I guess, why not? We'll do that. And set PS touch sensor default pin. Boom. Merged, just like that. And so now, so you get an idea of like a complete CI system, even though you have these crazy dependencies like hardware itself. So CI is possible with these IoT modules. All right, so now let's go back to the slides for a sec. And let's go take a look at some IoT modules that are out in the wild. So the first one that you saw in the video before was the LED matrix. Now this is by a community member, Tom, and he, yeah, the code is here in the link. And that's a 2D LED matrix powered by I2C. You can take a look at the code there. There's also this one, the ADXL345, which is an accelerometer. And the demo that Julian did at PSConf EU, which I was not there for, but I heard that he did the whole write progress thing that you saw me do, but with an accelerometer. So he had like X, Y, Z, and he would like move it around, and all the things would like go across, and it was really cool. So accelerometer powered by I2C. That's actually in the PowerShell IoT examples repo, or a part of the PowerShell IoT repo in the examples. He contributed that there. But wait, now this is going to blow your mind. What if I told you that PowerShell IoT modules do not have to use the actual PowerShell IoT module? I know, it's a little weird to say. But there's actually a ton of existing .NET libraries out in the wild already that have, there's like a ton of them that are written in C# that were used for like miscellaneous things, like interacting with touch sensors or LCD screens or whatever like complexities you want. They're very specific to a piece of hardware. And they were written in C# for use with Mono and projects like this. So since we have all of these IoT libraries that are written in C#, we can easily wrap them in PowerShell commandlets. If you haven't tried to write a PowerShell commandlet in C#, I'd highly encourage you to check it out because it's actually fairly straightforward. But all these C# libraries that exist, we can wrap them in PowerShell commandlets, and they're pretty much ready to go. So I went to this website. Where's my cursor? Let's see. What? Looks like they're having some SERP issues. That's awkward. All right. Well, that was a list of a bunch of different components that are like popular components that you can add to your Raspberry Pi. Like, I'm trying to think of a few examples. There's like a camera that you can get for the Raspberry Pi, so you could have like a little camera. And in theory, we can wrap that in a PowerShell module that leverages that camera module. And then you could use the camera with PowerShell, which is really cool. But yeah, I looked at this list, and like most of them had C# libraries that already existed. So we can very easily wrap these in PowerShell commandlets and get started. So the example I have is this one, RPi WS281X-PowerShell by Daniel, another community member. And this is a video. And he got these Neopixel LEDs to work with PowerShell. There's a library called RPi WS281X C#, and he wrapped that in PowerShell and is able to control these using PowerShell, which is really cool. All right, so that's another way to go about doing some PowerShell IoT stuff without necessarily using the PowerShell IoT module. So another cool thing to check out. All right, now let's just wrap things up here. Because I bet you all are very, very hungry. So PowerShell works on ARM devices like Raspberry Pis, and that's both Linux and Windows. These are they're still marked as experimental, so don't depend on them in some crazy scenario, but it's still really cool to mess around with. PowerShell IoT is, as I've said, a framework for building hardware-specific modules on top of PowerShell IoT. And then to look out for a bunch of .NET libraries that work with specific hardware that we could potentially wrap in PowerShell commandlets so that we have access to that hardware in PowerShell to grow the IoT PowerShell world. All right, so then I have a slide that just has all of the links on how to get started. I'm sure you may or may not want to take a picture of that. That includes the steps on how to install PowerShell on Raspbian. It's like 4 commands. It's super easy. Like Jeffrey said in his talk, it's X-copyable, so it's like really easy to get PowerShell on Raspbian. PowerShell remoting over SSH. There are some pretty clear steps in that link, which is a very long link on how to get that set up. And then also the PowerShell IoT repo is there, and the PS touch sensor repo that I made for this talk is there as well. And then the Azure Pipelines agent on Linux steps are here. And one gotcha is that they might not have done a release, an official release of the one that works on Raspberry Pis yet. So you just have to potentially get it from GitHub itself. But there's an official release there. And that's pretty much it. I have a blue screen afterwards. I don't know what that was supposed to be, but it's a blue screen, which means that's it. That's all I have for today. Yeah, so I guess if you have any questions, I can answer them now. Otherwise, feel free to go to lunch. Yeah.
So I have one. If you are testing against this, like you have the build pipeline and everything, how do you normally do it if you need to have the sensor in multiple stages? Or how would I approach this problem? Like have multiple Raspberry Pis with set to a different hardware state?
Yeah, that would be one way to do it. It's very easy with the Azure Pipelines agent to just like have a bunch of Raspberry Pis that all could manage some sort of state of like what hardware configuration that you were trying to achieve. The focus of like this talk, and I think what might be a good approach, is to just focus on like one particular piece of hardware and then just try to test it in that state. I'm trying to think of an example that like applies to what you're talking about. I guess maybe if you had like, yeah, like what would be a good example for what you're talking about?
Some managing some hardware, like we have something that has to get the drive out of failover state into normal state and test it. It's like very expensive phone test, but for that to carry it out, we need to get it into some state.
Right.
So here you have a cursor that, or a sensor that makes your test interactive. So if you don't press it, or if you don't touch
Right.
it, the test fails.
Right. That's definitely one of the challenges of like IoT tests, because now you have this hardware that you have to deal with. But one of the things that I've seen in Azure Pipelines, for example, is you can have different agent pools. And so in theory, you can like dynamically pick which pool you want to send the test to. And so, you know, in this case, it's this with nothing attached to the touch sensor, but maybe I have this other Raspberry Pi that has another touch sensor attached to it, and there's something touching it. And maybe you have two different pools in Azure Pipelines that specifies, you know, these are the touched ones, these are the not touched ones, and then you can like test against each of those different pools. There's definitely a way to like set up different environments and that sort of thing, and then like run the tests against those particular environments. And like I know Azure Pipelines gives you a bunch of like environment variables that let you determine what environment state you're in. So then you could potentially like skip tests that you don't want to run on a particular state, and you know, that sort of thing. So I'd probably do something like that. Yeah. Anybody else? You had a question before.
How much to get set up?
How much? Yeah. So a Raspberry Pi like this is like $35 US dollars. That's never something I have to clarify. So it's really quite cheap for what you're getting. And then the components, I got this touch sensor as a part of like some big sensor thing. Let me see if I can find it on Amazon or something. It was relatively cheap. I actually got the touch sensor as a part of a like components from a gift. Components, Raspberry Pi. So let me see if I can find it. I mean, there's stuff like, I got this one before, which is like the Raspberry Pi and then just like a bunch of other stuff along with it. And then the other big one that you'll see is Arduinos. And PowerShell doesn't work with Arduinos today. Here it is. I think this is the kit. because .NET itself doesn't work with Arduinos, but it was a similar kit that I got this touch sensor. But essentially, you see it's like $30 and you get like all these different sensors. There's like a joystick, an IR emitter. Oh, that'd be really cool with PowerShell to have like a remote water level sensor. So one of the demos that we did at the last PS Summit in Bellevue was a plant watering system where we had like one of these water sensors in the soil, and then it would like detect if it was wet, and then like if it is dry, it would like turn on a motor that would then water the plant and stuff like that. It's very cool. I don't know if there's a recording for that anywhere, but I think that code is on the PowerShell IoT repo. But yeah, there's just a ton of good stuff here, and other places to buy things work as well. But I was just using Amazon as an example. So yeah, it's relatively cheap when you think like a new computer is like $1,000 these days. So yeah, $35 plus maybe like $30 for components would be a good entry, a good starting point at least. Okay, anything else? No? Okay. Was that cool? Did you like that? Yeah, so I guess if you have any other questions, feel free to find me. Which? A wireless sensor? Like for like what kind of wireless are you talking about? Oh, IR? Yeah. I mean, I don't think we have a specific example of using like this IR emitter, for example. But in theory, this IR emitter is simply GPIO. You can see there's like 3 pins. There's like 3 pins there. One is going to be like power in, power out, and then like the signal. So in theory, it would be really simple to get started with that if you have this sensor. And it looks like there's both the IR emitter and then there's probably the IR receiver somewhere in here. Yeah, there it is, over here on the left side. And so in theory, you could use PowerShell to both emit and receive infrared stuff, which would be really cool. Yeah. So yeah, it's possible for sure. All right, cool. All right, well, thank you so much for coming, and enjoy the rest of the conference. Yeah, sure. If you wanna mess around with it, you can. Ooh. Oh, I'm not remoted in. Oh, so this is power. Yeah. There's no connection to my laptop. I'm just entering remotely. Yeah. Yeah. Sorry, I guess I should have clarified that. The Raspberry Pis used to not ship with a Wi-Fi chip, but now they do. I don't know if they do Bluetooth as well. I have to check, but no. Okay, yeah. But you could easily get a Bluetooth adapter for that as well. But yeah, and so this was, yeah, it's super handy. In fact, what was funny is that since I came here, since the conference was in a Microsoft building, and I was messing around with this demo in my Microsoft building in Redmond, that like it already connected to the Wi-Fi. So it was really easy to set up, surprisingly. I was very terrified that was going to be a problem, but yeah, I guess let me redo that and you can see stuff. Yes. Yeah, the Microsoft guest network.
But you need to open the browser.
You're right, and I did that back in Redmond. But you could, yeah, that would be very difficult to do headless. That would be very difficult to do headless, yeah. But you know, that's actually a very weird problem in this space, is that it's very difficult to start headless unless you do things the right way. But yeah, I usually just like hook it up to a monitor really quick to grab the IP address, and that's pretty good.
Similar talk
Uh-huh.
on Raspberry Pi
Yeah.
using PowerShell. So I couldn't connect to the Wi-Fi.
Uh,
I used my phone's
oh,
Wi-Fi.
nice.
So yeah,
That's really cool.
that makes it fit.
Yeah, so here's that right progress example again. So if you want to like touch it, it'll show up on the screen there. Yeah, yeah.
Does it take my fingerprint?
It doesn't. It doesn't. So yeah, you go high, and then when you let go of it, it'll switch to low. And then this demo, if you were here for the raffle, is yeah, the screen kind of got messed up in the transit, but you see someone, the last winner, and I can like scan the QR code with this, and then it will display that on this screen as well. And this particular screen is one of the examples in the PowerShell IoT repo, which is github.com/PowerShell/ so many repos, PowerShell-IoT. That's the repo. And there's some examples here. So yeah, this is the screen.
It's really a question about the whole Azure pipelines.
Yeah, sure.
So how do you really get started with that? I think it's really awesome. You did your pull request.
Yeah.
And once you did your pull request, he automatically builds.
Yeah.
So I see there's a build PowerShell, but I'm kind of missing a link. How
Yeah.
do you connect that to? Where does he do the build now? So I'm getting like kind of mixed up.
Yeah, so I can walk you through it. So what you want to do to get started with this is go to dev.azure.com.
Yeah.
Actually, let me do this in a private tab so you see what I mean. File, new incognito, dev.azure.com, and it'll show you this. And then you can like, yeah, sign in and all that stuff. And so then you'll get this screen. And it will let you link your GitHub account to this, right? And then that way you see like my organizations, it's my GitHub username, and so it will like, it's very easy to like hit create project, and then it'll let you do this, and then I could do like testing, for example. I could create a new project. Yada, yada, yada. It takes a lot of time. Okay, and then it gives me my project, and then from here I can go over to pipelines, and the link on how to get the agent running will kind of walk through all of this as well, or the just regular documentation will as well. And so then I go to builds here, right? And then I hit new pipeline. And so then it will let me select the GitHub repository I want to hook up. We wait for all the loops, and then you see all of my repos, right? And so then I could do like, I don't know, it doesn't really matter what it is, but pick this one for example, and then you just do starter pipeline, and it will give you already an Azure Pipelines.yaml file. It'll actually like create a pull request with this file. Or maybe it'll just commit it directly. I'm not 100% sure on that. If you already have an Azure Pipelines.yaml file in the repo, it will detect that as well. And so then you can, I believe you can edit this. Yeah, you can edit this. So, you know, to say whatever you want it to do. And then, and this is explained in the link on setting up the agent as well. But if you want to add like a Raspberry Pi to your pool of agents that get the ability to run the builds that get fired, you go down here to project settings, and then there's a thing called agent pools, right? And then from here you could do like a new pool. And I already did this before, but if I were to do like whatever, make a new pool, then from here I could do that, and then at this step I then run the agent on the Pi, go through the steps that it tells you, and then it will like connect to this agent pool, and then everything just works. It will handle like when you submit a PR, it triggers Azure pipelines, which will then go down to the Pi and like have it start the build there. It sounds like this crazily complex system, but they actually do a really good job of like making it really simple. It looks very intimidating, but it's actually super simple to set up. And that's not like I know I work at Microsoft and I'm pitching Azure pipelines, but like I have to say it's been really cool to mess with. And if you're not doing this for like Raspberry Pi project, you're just doing it for like whatever, like a normal PowerShell module, for example, then you don't need to deal with this agent pool at all. You can just go to builds, do a new pipeline here, and then if you noticed when I clicked this one and did starter pipeline, it has a pool already here. And so in this case, it's giving me a VM image of Ubuntu 16.04. And this is hosted by Azure DevOps, Azure pipelines. And then you don't have to deal with configuring an agent at all. It just like in AppVer and just like in Travis and other CI systems, all you need to do is really check this into your code, and then things just start working. You have CI. And all of this is free as long as it's an open source project. Actually, I think it's free private repos as well. Okay, that makes sense. Yeah. So yeah, it's pretty simple to get started. Just so you get a sense for where you need to go, it's github.com/. You can go to my repo for this talk.